Okay guys, welcome to this GCSE Maths, exam style questions, for the paper 1 exam. So I got these questions here from the AQA 2020, summer paper, and it's appropriate for exam revision for your paper 1 exam, which is this upcoming GCSE 91 Maths on Friday, May the 19th, 2023, So yeah, it's not actually long now, guys, so this is question number 1 actually, circle the fraction that is equivalent to 4.75. Well, I've got 4 wholes, now 0.75 as a fraction, hopefully you're happy, that's equal to 3/4, so it's 4 3/4, so this is what I call a mixed number. It's a whole number plus a proper fraction. Now to change this into an improper fraction, it's going to be out of 4, so it's going to be out of quarters. I do 4 times 4, which is 16, and then I add the 3 and I get 19. So the fraction that is equivalent to 4.75 is 19/4, which is going to be option number 2. So 19/4. Another way of doing it is recognizing that 4 wholes, equals 16/4, because 16 divided by 4 equals 4. Remember that line means a division in maths, and then you're adding on 3/4 here, which is equal to 0.75. That will also give you 19/4, because 16 plus 3 is equal to 19. When I'm adding fractions, I add the numerators but keep the denominator the same. So that is another way there. Question number 3, which one of these is a square number and a cube number? So 100 is a square number because the square root of 100 is equal to 10. However, 100 is not a cube number, because 4 cubed is 64, and 5 cubed is 125. And 100 is between 64 and 125. So it's not actually a whole number there. It is not what I call an integer. So that rules that one out. 1,000 is not a square number, but it is a cube number. So the cube root of 1,000, if you're interested, is equal to 10. Because 10 times 10 times 10 is 1,000. And there is like a little trick here. Because I've got 3 zeros, I can knock off 2, and whatever that number is left, if it has got a 0, then that will mean that it's a cube number, if that makes sense. So that one's not a square number here, but it is a cube number. This next one, this is a square number because it's got an even amount of zeros. And this one's got like an odd amount of zeros here, which obviously makes it also a cube number. So this one, the square root of it gives you 100, but it's not a cube number, for the square root of 10,000. Sorry if I'm actually waffling there a bit, but hopefully it makes sense. So that one is incorrect. So that one's a no-go for a cube root. That one's no good for a square root. That one's a no good for a cube root. So this it has to be that one here, but let's just check it. The square root of 1,000,000 is actually equal to 1,000, because you would obviously knock off 3 zeros if you're square rooting. And the cube root of 1,000,000 will actually be 100. So I would knock off like 3 lots of 2 zeros. So I'd knock off 1 and then 2 there, and then that would it's like your 3rd 0. So that would obviously be 100. So 100 cubed, or 100 to the power of 3, means 100 times 100 times 100, which equals 1,000,000, or 1,000 squared. If I square 1,000, 1,000 to the power of 2, or 1,000 squared, we say, that will give you 1,000,000, and 100 cubed gives you 1,000,000. So the answer is that one there. That's my answer for that question. So sorry I'm actually waffling a bit there. Question 4, again, it's not in any particular order here. Circle the reciprocal of 5/6. So it's just flip the fraction actually upside down. So it becomes 6/5. So So you flip the numerator and denominator upside down. Yes. So the denominator goes to the numerator and the numerator goes to the denominator when it's a reciprocal. Okay. Reciprocal just means 1 over. It's 1 divided by 5/6, and if you divide by a fraction in maths here, you multiply by its reciprocal. So you multiply by 6/5, which gives you the answer of 6/5, because 1 times anything is just itself. Okay, so the reciprocal of 5/6 is equal to 6/5. Okay, you are flipping, okay, the fraction upside down. Okay, so the denominator goes to the numerator and the numerator goes to the denominator. Okay, for your new reciprocal answer. Okay, the reciprocal of a 6th, if you're interested, actually that'll be 6 over 1, which is going to be 6 if you're interested. Okay, that one would obviously be minus 6 for the reciprocal, and then this one would actually be minus 5/6. Okay, if you're interested. Okay, and the notation here for reciprocal in maths is power of -1. So it's saying here 5/6 to the power of -1. Okay, the -1 just flips it, it inverts it. Okay, so it goes to 6/5 to the power of 1, which just equals 6/5. Okay. Okay, question number 19 actually, so like jumping a bit here. Circle the expression that is equivalent to x/5 plus x/10. Okay, so we're adding algebraic fractions, so I've got to have a common denominator. So I'm going to change this x/5 or x over 5 into tenths by timesing top and bottom by 2. So I get 2x over 10 plus x over 10. Okay, when I add fractions, I've got to have the same denominator, so the same bottom number, and I just add the numerators, so collecting like terms, 2x plus x equals 3x over 10, okay? Because you are adding 1x, remember, yeah, so think of it as adding 1x. 2x add 1x equals 3x, so your answer is 3x over 10. Question 20a, write down the value of 7 to the power of 0. Well, anything in maths to the power of 0, any number or any letter to the power of 0 is equal to the number 1, okay, apart from 0 to the power of 0, okay, because that's actually undefined, okay. So apart from this special case, okay, any letter or number to the power of 0 is always equal to the number 1, okay. And another fact in maths, okay, anything to the power of 1 is just itself. So 1 to the power of 1 is 1. 2 to the power of 1 is 1, okay? So anything to the power of 0 in maths is equal to 1, excluding 0 to the power of 0, and anything to the power of 1 in maths is just itself, okay? So some important facts here to remember. For part B, work out the value of 32 to the -3/5, okay? So a bit more challenging. So the minus does the reciprocal, so it'd be 1 over 32 to the 3/5. Okay, and now I've got like a fractional indice. Okay, so it's going to be 1 over, now I take the root of my denominator, so it's 1 over the 5th root of 32, we say. So the 5th root of 32. So what number do I times by itself 5 times to get 32? That will be 2, because 2 times 2 times 2 times 2 times 2 is equal to 32. So I'm going to have 1 over 2, and I'm going to raise it to the power of the numerator. So I'm going to raise this to the power of 3, or I'm going to cube my answer. So I get 1 over 8. So my answer is just 1/8, or 1/8. Okay, question 26a, show that 14 over root 7 can be written in the form a root b, where a and b are integers. So I've got to rationalize the denominator. So I'm going to multiply top and bottom of the fraction by 1, but I'm going to write 1 as root 7 over root 7. Okay, so I'm going to express 1 as root 7 over root 7, which will obviously become clear in just a moment. Okay, when I multiply fractions, I multiply the top parts together and the bottom parts together. Okay, 14 times root 7 is going to be 14 root 7, and root 7 times root 7 is root 49, which simplifies to the number 7. So I'm going to have 14 lots of root 7 all over 7. Oops, sorry about that. All over 7. Okay, That's going to simplify to 2 root 7 because 14 divided by 7 is going to be 2. So I'm going to get 2 root 7. And that's my answer for that one. Okay, so if you're interested, A would equal to 2 and B would equal to 7. Okay, question 26b, work out 2 root 10 times root 80 times root 18. Give your answer as an integer, so it's a bit more trickier. So I'm going to do root 10 times root 80 times, root 18 here in one go, okay? So I'm going to have here 2 lots of, okay? I'm going to have 10 times 80 times 18 here. So again, it's testing our mental maths here, okay? So 10 times 80 is going to be 800. So I've got 800 lots of 18. Okay, to make it easier, I'll do 18 times 8 and then add on the 2 zeros. Okay, well 10 times 8 is going to be 80. And then 8 times 8 is going to be 64. So I'm going to do 80 add 64. So that's going to be, so 0 add 4 is going to be 4, and 8 add 6 is going to be 14. So 4 carry the 1, you're going to get 144 there. So you're going to get the final answer here to be 14,400, okay? Now this one here obviously is a bit more trickier, and it is obviously like a non-calculator. Hopefully you're happy with the square root of 144 is 12, okay? And then if I add on a 0, okay, that will be my answer, because the square root of 14,400 is 120, okay? Because essentially you are like adding on a 0 here by that here, and by adding a 0 here, if you square like a 0, then it adds on like another 0, hence why I get 2 zeros here in my answer for 14,400, okay? But the square root of 144 is 12, okay? And because I'm squaring it, I'm putting on like two more zeros there. If I add on like an extra 0 here to 12, then if I square 120, then that will give me 14,400. Okay, so 2 lots of 120 is going to be 240, guys. And that's the answer for question 26b. Okay, again, that was actually pretty challenging. Question 28, factorize fully this quadratic expression. So taking out the highest common factor, which will be 4. So 4 lots of 36 make 144, and 4 lots of negative x squared makes the minus 4x squared. Okay, so 1 mark here will obviously be given there. Now the next bit here is a bit more sneakily, is recognizing that this is what I call the difference of 2 squares. So I'm going to have 4, and then I'm going to have a double bracket here. So I'm going to have 6 plus x times 6 minus x, okay? So remember here, difference of 2 squares, actually, so remember, it's a number squared or a letter squared, subtract a letter squared or a number squared, okay? So 36 here is what I call a square number, okay, because I can write that as 6 squared, which will obviously make it a bit more obvious, and then from there to there, that will obviously make a lot more sense, okay? But obviously, the first step here is obviously factor out obviously that here, and then recognizing that 36 is a square number, okay? The square root of 36 is 6, guys, okay? So your final answer is 4 lots of 6 plus x times 6 minus x. Okay, and that's my answer for that question. Okay, right guys, that's the end of today's video looking at exam style questions for paper 1. Okay, this is obviously for AQA here, but it's also appropriate for NXL paper 1 and OCR paper 1 here for the higher tier as well. Okay, if you found this useful, please do consider liking, subscribing, sharing, following, okay, and commenting your topic requests, and I'll see you all inside the next video, okay, for more practice for exam style questions for your upcoming paper 1 exam, okay? It's a non-calculator exam, okay? Thanks for watching, okay? I'll see you soon, okay? Bye for now. Take care. All the best.